Welcome to Yosemite National Park in California. This majestic landscape of high cliffs, trees, just raw sheer beauty. Here we are looking up at the northwest face of Half Dome. So this is the sheer face of Half Dome, the vertical face that you sometimes see when you see it from a distance in profile view. And today we're going to spend a little bit of time looking at what is now, in current times, the most dominant hazard and landscape forming process here in Yosemite National Park. So when you think about Yosemite National Park and you think about what's shaped this landscape, you think about glaciers, and for good reason. All these domes, the glacial polish in the high country around Tuolumne Meadows, the U-shaped canyons, the hanging valleys, the waterfalls are all a result of the passage of ice and the embedded sediment in that ice moving over this granitic bedrock and scouring and shaping the landscape. But the glaciers are gone now, and they've been out of here for a few thousands of years, maybe 10,000 years or more. And so the ice no longer occupies this area. And so what is the process that dominates here in Yosemite today? And the answer is rockfall. And we're standing right below an area here called Awaya Point near Half Dome. So that's this point just above me here, and you can see this big scar, white scar on the rock. And so we're standing just below where this huge collapse occurred on March 28th of 2009. This is one of the biggest rock falls in Yosemite since 1987. And so these rocks fell off this cliff face here, landed on the slope here just beyond the trees, and then tumbled down and went all the way down to the creek in the valley bottom in this direction. Took out portion of the trail, which had to be reestablished, and deposited all these stark white boulders that surround me here, these chunks of Half Dome granodiorite that surround this area. So this was a big event, and the impact from this rockfall, the ground shaking, was equivalent to about a magnitude 2.4 earthquake. So it was a really, really large rockfall, and it's still an area of concern. So this is this is a common occurrence here in Yosemite, these rockfall events, to the point that Yosemite, I believe, has employed for a number of years, maybe a couple decades or so, their own park geologist. And one of his main tasks is responding to these rockfall events. Rather than have someone at a university tracking and recording these, or the USGS, the park actually wanted to have their own on the ground, living here more or less year-round geologists that could respond to and monitor these rockfall events. And so these are pretty common here. They happen every year. Usually they're quite small, nothing on this magnitude, but they're an ever-present hazard here in Yosemite National Park. So let's take a look at both the rocks we see here and also a little bit with the rockfall deposit itself. We can see this just pile of angular boulders. We just walked back through a section of trail there where there was a lot of smaller rocks that were probably, when some of these boulders fell and hit the ground, they shattered and shot debris and smaller particles of rock out into the forest. We can also see here the lack of mature trees. The small little squatty trees that you see before you are the ones that have regrown in the, I guess it's what, 14 years or so since the rockfall event took place. So it absolutely decimated the trees that were here and radically changed this slope and this environment. So let's take a look at the rocks a little bit, and then I want to show you a couple things down along the trail. So one of the nice things about the rockfall event from a geologic point of view is you provide fresh exposures of this rock. So these rocks breaking only 14 years ago provides a wonderful fresh exposure for us to look at. And so this granodiorite, probably the most notable crystal that we see in here are these rectangular elongated hornblende, or sometimes they're called amphibole crystals within it. Let's maybe head over to a nice shiny face here. See if you get to see anything else. If you catch any reflections in the light there, those would be feldspar crystals, so either plagioclase or potassium feldspar. There's quartz in here, which is kind of a smoky gray, somewhat translucent look to it. And then some of the little black specks are actually biotite, like the real shiny ones. Hopefully you can maybe catch that one there, catching the light a little bit. So that's a little bit about the mineralogy that makes up what's called the half dome granodiorite. Let's see if we can see any other cool features in here. This rock also has within it, in places, chunks of older rocks that were embedded in it and trained in the magma. So we've got like a little dark xenolith right there embedded in the magma, and you see these in a few places throughout the rock. The other thing you see in here in places, I think I saw a better one down by the trail, so let's go check out that one. And there was a couple other interesting things to see there as well. Let's just head back down to the trail. We're just a few feet above the trail here in this sort of devastated, shattered zone. So if we head down here, they've reestablished the trail, and in places they must have had to really blast out or quarry some of the rocks. You can actually see a drill mark right here, that little cut into the rock where they had to, another one right here, where they had to actually bust open some of probably the bigger boulders that were blocking the way of the trail. A couple more on this boulder here. But here, this is actually something I wanted to point out in the rock, and that is really nice exposure here of the distinct change from the granodiorite here on the left with the large dark crystals in it. Then there's a sharp contact right here, and then the more fine-grained material without the dark mineral. So this is actually called aplite. This would be a fracture in the granite that later has magma move through it and crystallizes out whatever's left of the magma melt, which usually at this point is depleted in the iron and magnesium and ingredients needed to make the dark colored minerals. And so you end up with a more light colored, usually white to kind of pinkish material. So there's a nice aplite dike there. And then there's another one down in here that's maybe a few inches wide. So pretty cool. But the main idea here and the main theme is rockfall. And why do we have rockfall events occurring here in Yosemite? What are the triggers? And there's actually a couple. So think about granite and how it forms. It's magma that's underground. It forms with a lot of pressure on it as that magma cools and crystallizes. There's rocks surrounding that magma body. When that magma body cools and crystallizes into rock, into granitic rock like this, and then it's uplifted and exposed, the pressure that used to surround that material is now gone. So the rock actually expands outwards and exfoliates and breaks into little layers. And so we've seen that in a number of places here in Yosemite. The other thing that's happened here is these U-shaped canyons that used to be full of ice. The ice was providing pressure, outward pressure on the rock surface, but now that ice is gone as well. So this rock is very much in an expansive mode with both the way it formed millions of years ago and the removal of the ice more recently. And then you add into that equation things like rockfall, or excuse me, things like frost wedging, freeze-thaw cycles in the rock. They are going to cause those cracks to expand outwards. Other triggers that might play into this as well would be things like local and regional earthquakes, anything that destabilizes the rocks. You get heavy rainfall or even snow melt events into the fractures. Those can all precipitate these rockfall events, and it's no excuse me, no wonder that one happened in March. That would seem to be a peak time to me for these rockfall events to occur. So at any rate, hopefully you enjoyed this little video and this little look into the dominant landscape process here in Yosemite National Park, just below the northwest face of Half Dome. Thanks again for joining me, and we'll catch you next time from another great spot.